All right. Welcome, everybody, as we're just waiting for the top of the hour before we get going. Thank you for joining us early. Tom, are you feeling ready for this one?
Yes, I've evicted my dog. It's not in the room. There's going to be no barking this time, I hope.
Never work with children and animals. So you've got rid of one of those in the...
I thought you were going to say never work with children or AI. That's not what we're talking about today.
No, that's just, yeah. But it could be a future webinar topic.
It's definitely the thing. My AI demos are always entertaining. It'll never does the same thing twice. It never does what you're expecting.
Wow, that's the
one of the things you know in Claude, it has that thing where it gives it it gives a like a little comment of what it's doing, like pondering and stuff like that. Sometimes it says tomfoolering. And like literally, like when I'm doing a demo, it will say tomfoolering. I'm like, oh man, this is going to be bad.
Yeah, that's a bit too close to home, really, isn't it?
Yeah, yeah.
I always think that when Claude does that, I think, wouldn't that be great if humans could give you the same kind of commentary as they're thinking, just so you know where you stand in those long pauses.
You kind of get it from people's faces, though, don't you? You get like,
Yes, exactly. Hello again, everybody, and we're just having a quick chat before we get going. We'll start in a few seconds. Just want to make sure that everyone's got a chance to join that signed up, and there were a lot that signed up. So thank you, everybody. Yeah, it's going to be good. If you joined us at the Sonar Summit, good to see you or have your presence here again, of course. It felt like yesterday that we were just spending the day talking about all things in the world of coding. Great session.
It was lots of fun. Yeah,
good. It really was. It really was. Okay, well, it's 1 minute past. Why don't we get cracking? So let's say an official hello and welcome, everybody. Thank you for joining our webinar, How to Ship Enterprise Quality Code with AI Agents. And if you have joined any of our previous webinars, which I'm sure you have, hello again and welcome back. And today we're asking a simple but I would say urgent question. How do we ship enterprise quality code in a world where AI agents are writing more and more of it? And I believe in this webinar, Tom will introduce SonarQube Agentic Analysis. And we'll talk about the inner loop and the outer loop, and all things related and in between. So introductions first, though. I'm Andrew. I'll be your moderator today. And I'm excited, of course, to have Tom with me here. And just as always, a few quick housekeeping points on the next slide, Tom, if you can move over to that one. We'll aim to go on no longer than 45 minutes, Q&A at the end, but you've always got the opportunity to post your questions from now in the Q&A tab that you can see top right of your screen. And that's important because we've got Prasenjit, a colleague of ours, who's there and ready to answer any of your questions live and from this moment on, so don't hesitate. But of course, if you want to upvote any other questions you see, please do so. And we'll save some of the most interesting ones for the end. We're going to record the session and we will send out a link via email in the next few days. And finally, if you want us to contact you, there is under the poll tab, I believe you can request that we do that. Finally, at the very, very end, we'll be looking at a survey. You can take that survey at any point during this session, but it is there and we'll remind you again at the end. Now, Tom, if you move to your next slide, I'd love to introduce you properly. So joining us, as I said, is Tom, director of our AI engineering engagement at Sonar. And Tom has more than 30 years, you wouldn't believe it by looking at him, 30 years of experience in software development, product management and engineering practices. And he's helped teams adopt modern ways of building software, which is really a focus of today, of course. Yeah, so I know, Tom, you're all about how developers can build using efficient AI and agentic-centric development cycles today without compromising on code quality. So with that introduction, I'd love to hand over to you.
Absolutely. Thank you, Andrew. Okay. So let's start with the big question. I guess it's like the $1 trillion question right now. Can we actually ship enterprise quality code with AI agents? So Andrej Karpathy kind of has done some great, well, he's talking with some great quotes at the moment and sharing some really great content around this. And obviously he's really, up on what's happening and excited by the change that's happening to software engineering. And as of most people have discovered, the agents discovered what you can do. We can now knock up applications in hours instead of weeks. We can generate really impressive code very quickly. However, in the enterprise, we don't tend to move quite at that speed yet. And we probably shouldn't be, right? We kind of know not to deploy this code straight away. Going back to my 30 years of experience, this does remind me a bit of the 90s when we had the World Wide Web. And all of a sudden, people were doing amazing things with it, building websites, building web applications. But it took a long while for the enterprise really to catch up. And I mean, that's because we have a higher standards and there's a lot more at stake when we deploy things. And what did it take to get to that point where we could? I mean, it took new processes. I think kind of agile software engineering really came out of the web. It really came out of that. And, the technology was there to deliver faster, but we needed processes around that allow us to deliver faster. Obviously, cloud native engineering kind of came out of that as well. That allowed us to deploy much more quickly. And together, everything really started to working, and now most things are web-based. And that works pretty well. Although now we're obviously moving to command line again, but hey, that's another story. So yeah, I think this is really about adapting the processes and adapting the tooling for the new technology, and that's what will enable us to do this. So, what are we seeing so far? There's a few studies coming through. There's lots of kind of stories coming from organizations. But this study from Carnegie Mellon, I think, is a good one, where they looked at Cursor. They looked at, I think there's a lot of developers using it. It was thousands. I've lost the number here now. But when they gave people Cursor, they saw an immediate increase in velocity. They kind of measured commits, which I guess isn't exactly velocity, but it's an indicator, right? And lines added, so lots more lines added of code. And this was big in month 1, not quite as big in month 2. But by month 3, they were back to the baseline, back to where they were before AI. So why did that happen? Well, if we look to the right, we can see some other things change. So static analysis warnings went up. And interestingly, they didn't go back down again, or not very much. Duplicated line density went up a bit as well. And I think perhaps most importantly, the code complexity went up as well. And I think, as experienced engineers, presuming you are, we all know that when those metrics go up, it's probably going to slow down our development. And so the initial speed that you're getting from being able to generate code quickly is quickly offset by the problems caused by the lower quality code. So the bugs in the code. And that stops you in 2 ways, right? You've got to fix bugs as they come through. You probably didn't notice them, so your bug backlog is growing. But then as the code complexity increases, actually adding new features becomes harder, right? You've got more to understand. There's probably a whole bunch of code in there that you don't even understand, right? So it becomes very difficult then to modify that. And so I think if we're actually going to benefit from agents, we're going to have to avoid this problem, right? We know that code quality still matters. It still impacts our ability to deliver software in the future. And so we've got to always get it right. And code quality problems compound all the time. And once they're there, very hard to remove. So we can see straight away that code quality is important. And then I think we then got to sort of jump back to well, but hold on a minute. Are people not just creating those applications in days, right? They've got multiple agents firing things up. They're not worrying about code quality, and they're delivering stuff. And I think what we see is those applications they're delivering are kind of in this more internal, non-critical side of software development, right? So we're generally less than 50,000 lines of code. They're probably short-lived. You don't really care about them, maintaining them for the future. You can kind of knock them up in a few hours and use them and then throw them away, right? It's a whole new thing. Probably not many users, maybe just you, maybe a few other internal users. Certainly not kind of millions of kind of users all around the world. And I think talking to customers and organizations, this is where they're currently seeing the big gains, even in the enterprise, right? So you can knock up new data, data analytics applications and learn stuff about your internal data that you couldn't do before. And we're already seeing huge gains here. But I think what we're probably not seeing is when you get to the enterprise level production applications that are mission critical, that, for instance, in a bank have got all your customers' banking data behind them. We're not obviously seeing the speed gains there because there is a lot more that goes into the quality checks for those applications. So, and also they run for a long time, right? I mean, we have many customers that have still got COBOL applications that they're maintaining. They've been going for, what, I don't know, 60 years? I don't know. Maybe not quite 60, 50 years, let's say. But that's a lot to maintain. You need the quality to be good. And so for that level of software engineering, there's a lot more. There is a gap, right? The agents by default are producing a level that's good enough for vibe coding a personal app, but not good enough for an enterprise level app. And this gap is, we can call it verification debt, right? Debt. You've got to go through the code. You've got to check everything is understood. It's maintainable. It's reliable. It's secure. All those checks. And that's what slows us down. And so I think what this is going to be about is how do we close that gap, right? At the moment, if you just leave that gap to developers and just let them kind of correct all the agent problems, they may as well just start writing the code themselves in the first place. And I think lots of people are seeing this, right? In some situations, you can get very carried away with letting the agent write lots of code. And it's actually more trouble to try to fix it than it is just to write it yourself. And so that isn't sustainable. But I don't think that's an unsolvable problem, right? I think that's something we can solve, and we can get closer to closing that gap, bringing the agents up. And so what happens if you don't close that gap? Well, I think we're already seeing that in the news, right? So I won't go through all these. There's new ones every week, right? There's every week there's a new story of some big enterprise, some bug that's taken things down, reliability is reduced, new kind of software vulnerabilities being exposed. There's problems every day. I think the Amazon one was really interesting, where they basically gave a 90-day reset. They'd kind of generated a lot of code using agents. They were having reliability problems. They were becoming unmaintainable. They've kind of said, let's reset. That's super interesting. So obviously, if you don't fill that gap, it's going to hurt. So why is this happening? Why are the agents not developing, not writing the code at the quality we need? Well, you may have seen this already, but at Sonar, we've been benchmarking all of the LLMs for quite a while now. I think we've done over 50 models. And there's a leaderboard that I think somebody's going to link to now in the chat. But basically, this isn't like all the rest of the benchmarks. So we're running, I think, 4,400 tasks in Java. We're just doing it in Java so far. And yes, we're testing the success of those tasks, just like the other benchmarks do. But we're also, and more importantly, testing the code quality of the code that's generated to complete those tasks, right? So not only do you know if the code worked, but is the code maintainable? Is it reliable? Is it secure? And we do this using SonarQube, so it's something that we can do well. So what we really see from this is that every model is different, and a lot, and it really changes a lot. It's not like they're all incrementally moving. They're all really different. I mean, we see huge differences in the amount of code that's written to pass the tests. So you can have, in fact, let me jump to the next slide. So yeah, if we look here, we can see GPT-5.4 medium to run this benchmark where it passed 81% of the tasks. There's over 1 million lines of code, 1.1 million lines of code. If we jump to Gemini 3 Pro, it got 81%, pretty much the same pass rate, did it in 290,000 lines of code. So one is generating 4 times as much code as the other for pretty much the same outcome. I think as an experienced engineer, you probably, it's kind of raising some question marks there. What is the difference? But it's not just about the verbosity. The complexity is very different of the code as well. There's different, quite different amounts of bugs. So we can see the recent model, Opus 4.7 thinking, has quite a lot of bugs in it, right? The code that's generated, which is quite surprising, significantly more than 4.6. And then vulnerabilities as well. That really changes too. Now, generally, the more modern models are getting better. However, the bugs and the vulnerabilities that are there are becoming more complex and harder to detect. So they're not the more basic things, right? The models are definitely getting better at the more basic things, but then we're getting the harder problems, which in some sense is more difficult for you as users, because they're going to be more difficult to detect and potentially more difficult to fix. Okay. So there's a link to this leaderboard. Go and check it out. Have a look at the models you're using. I think it's really useful for our customers to get a sense of what they're working with effectively. It might be helpful as well if you're making trade-offs looking at different models. We've also haven't included the slide here, but we've also been looking at the remediation cost of the bugs in with the different models as well. We'll share that in a blog post, I think, soon. So yeah. Right. So that benchmark is basically just the model working with a task. It gets one shot. It returns the result, right? But that's not what software development looks like. In real software development, we'll develop one feature today, and tomorrow we won't know what feature we're going to develop, but it will come in and we'll work on that and we'll develop that feature. A good engineer knows that they've got to build the code today that they'll be able to extend tomorrow, because it's a continuous, software engineering is a continuous process, right? We don't just knock up one app and then leave it alone. It's a continuous process, potentially for years. But that's the benchmarks don't cover that scenario at all. However, there is a new benchmark which I found called Slop Code Bench. I'm really not sure about the name of it, but it's it's fun. It's really there to measure the slop that the models are creating, or the agents in this case. This is directly, our benchmark was doing models. This is actually you doing agents. So the slop that the agents are creating and how that changes over iterations. So when you keep adding new features. And so this graph you see here is a Python task. It's creating a code search utility. And checkpoint 1 is a very simple code search. Checkpoint 2 adds a new feature. I think it searches different languages or something like that. Code 3 has a different kind of search syntax or something like that. It keeps on adding them on. When I run this one in Python, the first iteration looked fine. 300 files, a few functions in there, all pretty readable, no problem, great. Then I ran 2, still kind of okay. Run 3. Okay, I'm going to run 10. So I ran 10 iterations to see what I got. I ended up with a single Python file, 6,000 lines of code, and functions that are 600 lines long. And what's happening here is for every task, the agent is doing the minimum it needs to do to complete that task without any consideration for the future of what's going on next, or without any consideration of the past. Agents generally don't delete code. They will just add code. They don't generally refactor code. They just keep patching the existing methods in the simplest way they can, which is the most efficient way for them to complete what you've asked. So without any guidance, this is what you get. Obviously, it's not sustainable, but it's a fun exercise to run just to see what will happen. And I think there's when people are vibe coding on this, they don't look at this code, right? And they don't look at what that's happening here. And it's pretty crazy when you start looking at it. So we tend to be, I think, most people are tending then to rely on human code review, which is what we've always done, right? Well, mostly been doing. We always have somebody else to review the code we've just written. And so we can review the agent's code, right? And surely we'll be objective and be critical of that code. However, there's some really interesting psychology going on with AI. We have a bias, right? And I think that bias is really understandable. Like when I'm working with AI, I find it really hard to be critical with it because it's just generated something that I couldn't have generated in that time, right? It's just generated some really nice code. It works. It did it for me. I'm feeling a bit lazy. I don't necessarily want to rewrite it all. We have some biases, and we often let too much get through, I think. There's a paper where they've kind of studied our sort of human interactions with AI and how critical we actually are. So it's by Shaw and Nave. It's a Wharton paper. And so when they ran all these tests, when the AI was correct, 92.7% of the time, the human agreed. So not bad, pretty good. When it was wrong, so they put incorrect answers through, 80% of the time, 4 out of 5 times, the humans still agreed, right? So if this is the case, if this is what's going on with our psychology, can we really be objective in code review? Right? I think this is a really worrying kind of area. I think we're not good at being objective with AI at the moment. I'm sure there's some great engineers out there that can do. Personally, I really struggle with it. So, well, we can get AI to review our code, right? I think everyone's kind of seeing the challenge of that. Now, I don't know if you've tried AI code review tools. I mean, they're good. They find some really interesting bugs. They can kind of help you understand the code. It's good. But they're not necessarily a good ground truth either. They're not necessarily objective any more than the original AI was, right? So they have the same flaws. I kind of liken this a bit to when I was coding as a developer full time. I would much prefer somebody sitting by me to when they were code reviewing my code, so I could tell them, no, that's right. That's, I did this because of this, and this is correct, kind of thing. I would influence them. I kind of feel that AI code review is kind of influencing us in a similar way, right? It's convincing us, it's just another AI, but it's convinced us that, okay, it's a more critical one, it's more correct, kind of thing, where it isn't necessarily, right? There's the same problems. There's still false positives there. There's still misses things. And most of all, it's you get a different result every time, right? You don't get the same results. So you might find an issue, you might not find an issue, you might find a different issue every time. So yeah, also a challenge. So this leaves us with a whole bunch of problems. And what can we do about it? So we're going to dig into verification. And obviously at Sonar, we've been about verification of code for a long time. Today, we're mostly going to talk about AI native verification. So we've built some new tools primarily for AI to verify the AI written code. And so before we jump into the solution, let's look at what the requirements are, right? So the first thing really is that any kind of verification needs to be complete as we can get. Now, I think we all know that through tooling, we cannot get complete verification. There is the Oracle problem, which kind of says there's an infinite number of things that you can test. We can't do that. It's really interesting to see that TDD and BDD are making a real comeback with AI, and I think that's great. I'm really happy to see that. And that allows us to verify against the specification. And it gives us this nice thing from this very kind of loose and maybe quite fluffy kind of prompt in the first place to the code. It gives us this in-between step, right? Here is the translation of the requirements that were given, and we can read through those tests and see whether they are actually the behaviors we want. Again, we've got to be critical if AI is writing the test particularly, and that's generally the case these days. But if we it's quite easy to cast a critical eye on those tests and try to think, use it as a tool, try to think about what is not there. Is everything there what we really want in the behavior? So TDD and BDD is great. Obviously with Sonar, we can test see the coverage of that. We can't actually see how good the tests are, but that's up to you. But that's definitely a good tool there. But then there's all the things that you don't specify, right? And these tend to emerge as bugs and vulnerabilities, and then potentially maintainability too, right? So you're probably not specifying that in your initial prompt, but we still need to control those three things too. So, the bugs are really the specification that you didn't specify in a sense, right? Especially if it's a logic bug of some sort. But we're trying to capture those things that fall outside of what you're going to catch in TDD and BDD. So that's the completeness side. I think the next thing is the thing needs to be auditable, particularly in the enterprise, right? We need it to be reliable. We need it to do the same tests. We need to run the same checks every single time, and be able to recreate those results. So you should expect in the same code, you'll always get the same results. And it should be traceable, right? We want to see, okay, when did this bug appear on the code? When was it removed on the code? And that isn't possible with the AI-generated code, but we can kind of track that. And then lastly, it needs to be efficient, right? So AI code review tools are very expensive. I think the Claude code review was sort of $15 to $20 per review per PR, which is obviously a lot. It doesn't do it super efficiently. The static analysis is kind of built to do this more efficiently, right? So it can do it relatively fast and cheap. And we'll talk about the speed a bit more later. So yeah, so bringing this together, sort of making this more AI native, we've come up with a process of agent-centric development cycles, right? So obviously we're used to an SDLC, but we're going, okay, what if the SDLC revolved around the agent? What if we kind of redesigned it a bit? And so we've come up with this concept, ACDC. And it's kind of made up of 3 steps, which are guide, verify, and solve. So I think guide is really interesting. I think I often think of AI a bit like a new developer joining my team. I wouldn't just kind of let him loose on the code on day one without giving him a whole bunch of context first, right? I'd be explaining what the coding standards are, what the architecture looked like. And in the same way, we need to make sure we're guiding the agent correctly. And this is definitely an art and a science at the moment, right? We are still learning how to do this effectively. But what I'll show you later is some tools that really help with that. Then the verification step with my new developer. There's no way I'm just letting him commit. We're doing some good code reviews. We're going through and checking. And then obviously with the feedback that comes from that, I expect him to go and solve those issues. And I think this is how we should think about the agent, and we need to provide this. But it's not efficient for a human to be constantly doing that. So we want to as much tooling to do that as possible. And so we've broken this guide, verify, solve cycle into an inner loop and an outer loop. So the inner loop is very much the tools working directly with the agent to guide, verify, and solve the issues. So that when the agent comes back to the developer, the code is already clean or cleaner than it would have been before. The outer loop is really the assisting the human in the loop process, where we've got a full analysis. We're doing as many checks as possible. And hopefully there's minimum issues raised in the outer loop because they've been solved in the inner loop by the agent. And so this is the way that we make that process of working with agents more efficient, by kind of guiding them and letting them verify their own code first. And so there's minimum amount of verification or minimum amount of rework needs to be done in the outer loop. So what does this look like in action? Well, if we go back to my code slot bench example I gave you earlier, you can see the difference between when there's no guidance, just let the agent run. And then when we add guidance, we can see a significant improvement. Now, this is measuring structural erosion, which is a bit like cognitive complexity, but it's looking for really high complexity functions that are going to be hard to maintain. It's just a slightly different algorithm used by this benchmark, but it's an interesting one. So we can see that guidance alone will significantly improve, right? And so this is what we can do with context, good context. We can get in the right direction. But the agent is always kind of limited. It's always making trade-offs, right? The agent's primary task, well, the goal is the prompt that you gave it. Everything else it may well ignore, right? All of the other context, it will use that, but it's not guaranteed that it's gonna use it completely. So the guidance doesn't get us all the way to the level that we want. So we need that verification as well. And then we can see that when we have both guidance and verification, we get down to a really nice baseline of clean code. It's worth pointing out that if you don't have the guidance and just the verify, you could get to the same result. I must admit, I haven't tried it, but it's going to be a lot more inefficient. You're going to use a lot more tokens doing it, right? Because you are constantly reworking. You haven't given it the guidance in the first place. It doesn't quite know what it's going for. It will constantly rework till it hits the right result. So yeah, just like when we're working with humans, guide first, then verify. So how can we implement this now? Yes, how am I doing for time? Good. So I guess you already know SonarQube. I guess perhaps not everybody here does. If you don't, well, we're a zero trust multi-layered approach, right? It does a number of different checks at different points in time. We cover 40 languages. There are 7,500 different issue types that we check for, many for different languages. And it's now deeply integrated into the agentic workflow, as we'll show in a minute. There is also, which you may have missed, particularly if you've been on server and not on cloud, now an architectural management feature. And that is really important, particularly now we're working with agents where we want to get their maintainability. We want to control the architecture. So we're not going to do a deep dive into that today. If you haven't seen it, I think there's some other good resources to look at, but that's a fantastic feature. And that really expands what SonarQube does around code, technical debt. And then, yeah, it's now kind of integrated with MCP and CLI. So we'll get into that in a minute. So we're trying to build a good blueprint around this. We want to make the integration with the agents as easy as possible to install. There's a lot of tooling around at the moment. There's a lot of kind of quite tricky configuration, particularly with MCP. So we've put these tools into the main agent marketplaces. So there's plugins. So what I'm going to show today is Claude, but similar things are available for Codex, and we're implementing with other agents. So you can just find the SonarQube tools in the Claude marketplace. So if you're using Claude, go to the marketplace, just search for Sonar, and you'll find us and install it. And there's a kind of wizard that will take you through the process of installing. There is both an MCP and a CLI. Now, the MCP at the moment is very complete. There is a lot of tools within the MCP. There's not quite as many in the CLI at the moment, but the CLI tools are generally more efficient, and you can build them into hooks so they can be kind of run more deterministically. So at the moment, it's a bit of a combination of both. And that may well kind of evolve as things change, but that's where we are at the moment. Once you've installed that, it's about how do we want to configure it? What do we do to our Claude MD or our Agent MD to give it a process to use those tools well? And there's some good documentation, and I'll show you a few examples today, but there's some documentation in the tools of how to do that. You probably want to adapt that for your own processes. And I think the other thing is to monitor the impact of the tools, right? The interesting part about all of this is it's not deterministic how the agent will use the tools, right? You give it tools, you tell it what the tools will do, or we describe that in the tool descriptions. And the agent makes a choice of whether it's going to use them or not. And obviously we try and kind of configure them in a way that they will use them in the right place, in the right way, effectively and efficiently, but there's no guarantees. So you really need to kind of monitor whether the tools are being used as you expect or whether they're having the impact you expect. Because the agent won't kind of stop if the tool isn't working properly, it will just find another way around, right? Really annoyingly, sometimes it will just kind of make up its own SonarQube analysis if you ask it to do a SonarQube analysis, if for some reason it can't use the tool. So it's really important that when we set these up, we kind of monitor the output of it. And one of the things I'll often do, and I'm not sure it's in the prompts here, is say, show the SonarQube tool usage during your process, and you can kind of audit it. It will give you a table going, okay, I called this tool 3 times, did this, and you can see whether it's using tools effectively or not. And that's a good pattern. So let's start with the inner loop. So here's a kind of interaction diagram of it, right? So let's kind of just run through this. So the user comes up with a task. The agent then kind of will use tools to plan that task out. Now, I think it's really, really important when you're working with enterprise level code that you're using a kind of plan mode, or whether it's using plan mode or you're just asking it to plan first, doesn't really matter. I often ask it to give 3 options because it never gives the same option twice, and they can't all 3 be right. It will cycle through different options whenever you rerun your code. So I often ask for 3 different kind of designs to see which one's things. And I'm talking about architecture here mostly, right? But there's, as an experienced engineer on that code base, how you'd want to do this. If you don't specify that up front, ask for some options and it will kind of explore the code base. So the context augmentation service that I'll show you in a minute will kind of then return results back to the agent to guide it to make the right kind of choices in the design. Then when you're ready to generate the code, the agent will do that. Doesn't tend to interact with us as much then, but it can do. You can actually have a hook every time it kind of saves a file. But usually we usually instruct it that before it then presents the result back to the user, it then does an analysis of the code itself and fixes any issues before it comes back to the user. So this kind of box down here is where it's kind of fixing any issues. And generally, it can fix any issues with one loop, right? It doesn't usually take long. So the result of this is you've got given it good context. So it wrote the right code in the first place, and then it analyzed its own code and fixed any issues. So when it comes back to you, you've got verified code returned already to the user. It's ready for review, ready for a PR when the full analysis will run. So let's break into what that context augmentation did. So this is the first part, the guide piece. So the first thing it kind of does is asks, the agent will ask the context augmentation service for guidelines on what it's doing. And what this basically is a list of 10 kind of most likely Sonar issues that we think, based on the task that it's doing, it would raise, right? And so for example, if I'm going to work on a data access component on project X, it will ask for guidelines. SonarQube will go and look at the most relevant data access issues that have been found in the past on project X and come back with those guidelines. This has a really interesting effect. It reduces the number of issues the agent produces by quite a high amount. I forget the exact number, but it's around 50–60%. It actually seems to reduce other issues as well that weren't specified. I think it kind of gets in the mode of kind of SonarQube quality when it's doing this. And so this has a really nice effect. It's super simple. It can really help, right? So that's the first thing that's run. And the second thing is a little more complex, is the architecture. So as I said, we've now got an architecture feature in SonarQube Cloud. The SonarQube has kind of 2 parts to it. It creates a dependency graph of the current architecture during the analysis, which can be visualized in SonarQube Cloud. And you're seeing a kind of visualization here, or a segment of it. It's obviously large on a big project. Just basically showing all the dependencies, and it's got cross-language support. It has the same kind of abstraction on any language, and so the agent can pull that down and get a very definite map of the architecture. In SonarQube Cloud, the developer can also specify an intended architecture. So you can start this at a high level with maybe just your top level, right? I've got my business layer, I've got my data layer, I've got my UI layer. You could say which one maps to which and which ones don't, kind of thing. And you can go down, working down layer by layer to get as detailed or high level a kind of architectural model as you like. If anybody breaks that model, it will raise a SonarQube issue. And so get intended architecture gives the agent that model, and it can check that it's not going to create any dependencies that fall outside that model. And then there's actually a whole bunch of tools as well to help it navigate the architecture, right? So you can get a type hierarchy, for example. And this is something that the agent will try to do itself by kind of just reading the code, but it's hard to do. It will miss things. It won't necessarily be accurate. If it gets type hierarchy from the SonarQube tool, it will get the accurate one. We know this is because we got this from the build, right? So yeah. So this really has a good effect if you want to control your architecture and you want your agent to write within your architectural guidelines. We could also check for dependency risks. So if an agent is adding a new dependency, a third-party dependency, it can now go and check that there are no vulnerabilities, no CVEs on that dependency, that it won't fail the SCA, the advanced security checks later. And so we can preempt that and make sure that it's got the right dependencies. If it's adding any new ones, here's a kind of example of it doing that. There's a couple of methods here. There's search dependency risks that it can call, which will give it all the dependency risks on the project. But then there's a check individual dependency. So if it wants to add a new dependency, it can go and check that. So between the two, it kind of gets a good understanding of what's going on. And so once that code that's been guided, the code has been written, the agent then can go and verify the code. Now, we kind of knew that we had some work to do on the verification for agents, right? We want an agent verification to be able to do it very quickly, within a few seconds, right? We can't wait for a full, if you've got a very large project, it might be minutes to do a full analysis. We don't want to do that. But we also wanted a deeper analysis than you get with the IDE extension, right? Which is kind of limited because it hasn't got a full build necessarily. So the way we've developed this new service called Agentic Analysis that's still using static analysis, right? It's kind of the name, it kind of suggests maybe it's using an agent. It's not. It's just a static analysis piece. But it is mapping the new code that you've written against a previous analysis of that branch, which has got all the types resolved, has got all the data flows calculated. It basically does an incremental analysis of the two. So this gives us a result that finds 90+% of the issues, and we're increasing that all the time. We're making this more and more thorough and finding more and more of all of the issues. But it returns within a second, 2 seconds kind of thing, especially if you use it through the CLI. It's much faster through the CLI. So it's not slowing the agent down at all. So the agent can check file by file as it goes, or it can check a whole change set very quickly and get a pretty complete analysis. So if your agent is running this, you should get very few issues found in your PR when you raise the PR later. So yeah, I'm really pleased with this. It's so this is in beta now, and you can run this and try this if you're using SonarQube Cloud. I'll cover that a bit more at the end. And there's also the secret detection hook. So you may have seen we've got a secret detection CLI now that's been available for a little while. And the reason it's a CLI and not in SonarQube is you want to detect those as a pre-commit hook before it gets checked into Git. It's too late then. Once it's in Git, got to redo all your secrets. So this can be integrated into Claude. So you can integrate it into Claude. So in fact, even when it reads files, it's checking for secrets. And it can be integrated into Git as well, so that whenever you do a pre-commit hook, it will run this check and make sure not let you commit if there are any secrets detected on that file. So there's another way to keep your code a bit safer. We've all heard of agents committing secrets, and They're causing all sorts of problems. This is a good way to avoid that. So that's our inner loop. Let's go to the outer loop, which you're probably a bit more familiar with. Sorry, I'm just doing a time check. So the sorry. Oh, mess. Okay. So the outer loop. Yes. So you know this, right? We commit the PR. We've got the checks in the CI. I think they're going to become more and more important and more comprehensive as the needs grow with agents and the risks are realized. If issues are found in the PR, if they haven't been detected on the inner loop, then you've kind of got two options. So we now have the SonarQube remediation agent, which is a specialist agent to go and fix those issues, which can do a great job. It can also fix issues on your backlog of issues too. So that's also available in beta in cloud at the moment. Or you can pull it back to the original agent that wrote the code. You might find that works better and let that agent fix it. There are MCP methods that allow the agent to check the state of the quality gate and pull the issues down and read the description of the issue and how to fix it. So the agent can do quite an efficient job of fixing those issues too. So you've kind of got options there. And then ready for human code review. And obviously there are code review tools around to help that human code review. And we're also developing our own at the moment as well, which will just basically make that human code review easier. Important thing is that you have to be able to understand the code, and that can be challenging, and any other issues that can be found on that. So yeah, I've taken quite a bit of time. I'm going to go through this fairly quickly. Just really to say in the PR, I think it's becoming more important now that you can get the full reporting on the PR. So you can go into SonarQube, you can run the see any regulatory reports, how they're impacted. You can look at the metrics, exactly, keep a good eye on the metrics. There's a whole lot of talk about metrics now, trying to track whether the code quality is going up and down. So we can really get, using the SonarQube reporting, really get a good view of the impact of a PR. As I said, with if there are any issues, you can get an agent to either our remediation agent to fix those issues, or the coding agent to fix those issues before the human actually gets to it. So hopefully there will be in the PR fixes for the issues all ready to go effectively by the time it gets through. And then preparing for the human code review. And here's a kind of example of what our code review tool is going to look like when that's available, which will be soon. Okay, so I think I'm pretty much there. So quickly on these tools. So the context augmentation, the agentic analysis, which are available through the MCP, CLI, and the plugin, are all in beta now. So if you're using agents and you're not using the SonarQube MCP or the CLI or the plugin, give them a try. Go out and try that now. I mean, they work well. They're pretty easy to configure. Please send us your feedback. We want to hear more. We're in beta at the moment. Obviously, everything is changing so fast. It's kind of every kind of insight we get from customers is gold at the moment. And so, yeah, that's available. We've got the remediation agent is also available if you're on cloud. And yeah, that's pretty much it. I'm going to preempt the question about SonarQube server. Were you going to ask that?
You read my mind, Tom. You read my mind.
Oh, these available for server. So the MCP and the CLI are available to use on the server, but it's more limited, the tools that you've got within them at the moment. So there isn't the agentic analysis or the context augmentation available. Well, some of the context or the architecture isn't available, but the guidelines are. So it's a little bit complicated. But you get some of this. You can do enough in server, I think, to really make use of these tools. But if you're on cloud, you're getting the full experience at the moment.
Great. Tom, thank you. That was excellent. Wow. You managed to get through quite a wealth of complex information there, so kudos to you.
Yeah, I hope it was clear enough. There's a lot, isn't there?
There is a lot, but if people who want to learn more about what we've been discussing today, or just about Sonar and our solutions in general, because there are a lot of new solutions coming out all the time, particularly from an agentic perspective. Under the survey tab, you can leave your details if you want to be contacted. Don't have to, no pressure, but if that's useful for you, just wanted to mention that. Okay, so I know we are getting close to time. I did want to quickly just ask a couple of questions, maybe one for sure. Tom, will agents ever be able to write perfect code? Do you think we're going to get there?
I think they're definitely going to improve. That's for sure, right? The models are going to improve. I think there's perfect code is subjective, I think is the first thing, right? So it may be, I mean, there is no perfect code, right? So is it perfect code for you? That probably takes a lot of the right context and things. Even if the model is amazing, right? You've still got to be able to specify what you want in the perfect code. So I think this guide phase is always going to be super important, right? Even if the results are much more reliable in the future. And I think the verification will always be important as well. So, until we get to the point where the AI becomes deterministic, which we're just not even in the realms of possibilities at the moment, you're always going to get different results. So even if 99% of the time you're getting great code, you still need to verify for that 1%, right? And so we'll still need to do this work. So yeah, we may get close to perfect. I don't know quite what perfect is. It's subjective. But I think there'll always be a case for guiding and verifying. There'll always be a need for guiding and a good, strong case for verifying.
And, just looking at the chat and some other questions that came in, a theme was, well, first of all, there was a theme around documentation, which I know Prasenjit's been posting some links, or Emma has. And the documentation really is quite comprehensive, and it's a great way to look at how you can get started. But, if another thing that was coming through is, which tool should I start with, and where should I be placing it in my, in my build pipeline? Because it is new for some people, it's not for others. But how would you recommend people get started, Tom?
So, I mean, the outer loop is kind of all there for you, right? There are some things to turn on, so you can turn on the remediation agent. So they're available now. I think it's in the AI tools. I think they're in SonarQube Cloud if you're using cloud. So I guess this question is different for cloud and server, right? So if you're on cloud and if you're using an agent like Claude, then use the plugin, or just get installed on the plugin, run through that. It will give you the tools, even without any kind of context engineering. The agent will start using those tools, right? And so I think then just explore, play, kind of monitor what's happening. Really easy to get started. If you're on server, install the MCP is probably the best bet to start with now. You've got a whole bunch of tools. There's like 20 tools within the MCP still available. Have a look at those and start exploring those. You can make up you can do a bit more of a kind of hybrid inner outer loop. There's a tool available if you don't have the agentic analysis called Analyze Code Snippet, which isn't as complete as agentic analysis, but it will still find like 60–70% of issues. And so that you can still kind of do the inner loop work there. You can get guidelines from the context augmentation. You just can't do the architecture. So get started with the MCP if you're on server, I think is probably the best bet. If you're on cloud and you're using something like Claude or Codex, install the plugin.
Great. Thanks, Tom. That's great advice. I appreciate it. I think we should probably wrap up there. If you go on to the next slide, just briefly, Tom, I know that there are some more webinars coming up if people wanted to check those out. And yes, YouTube is definitely a good place to go.
Yes.
I saw that comment coming through. And I can see another question coming in about the CLI tool.
Yeah,
as
so
well.
CLI tool also work with server, but again, it's limited in the tools it has access to.
We can definitely follow up on these conversations rather than trying to compress everything into these last few seconds. So if you need to reach out, and we're happy to continue these conversations afterwards separately. But Tom, thank you. Appreciate it as always. And thank you to everybody who engaged in the chat. Appreciate that as well. And for those who submitted questions, if there's a question that we didn't answer to your satisfaction, or you didn't get a chance to actually type it because you were listening to Tom intently, then the community, our community forum is a great place to go and submit a question, and you'll get responses from our community, not just from us, which I think is a really powerful thing. Thank you for...
the teams that are developing this would love to have more feedback, and the community is a great way to engage with them. Please do post on that. We would love to get into more conversations about this. Yeah, definitely do that for sure. And there'll be more webinars coming up. So, thank you. Thanks for everybody. Thank you again to Tom, and we'll see you all at the next session, or maybe at one of our world tour events, which if you check on our website, we're probably coming to a city near you if we haven't already been there. So another good opportunity to come and talk live to us and talk all things AI for sure. Thank you. Goodbye, everybody. Bye. Thank you.